Hello and welcome to the next Nix Hour. If you want to ask a question yourself, feel free to join the meeting and ask via voice or chat. All right, so maybe, does anyone here have a question right away? Let's give a couple seconds. And if not, let's look at actually one issue here that we previously looked at, but there's a related question here, which I think would be interesting. And that is, I want to describe multiple NixOS configurations in a single flake. How can I refer between those configurations? For example, use a port value from config A as a setting in config B. And yeah, I think that would be interesting to take a look at. So let me go into here. Nix Hour 48. And I have a kind of template here, which I would like to use in the future, which just has, well, it uses a default.nix, it doesn't use a flake. But maybe let's use it with just a default.nix for now, but later we can change it to a flake as well. So there's a NixOS system declaration down here. And actually let me change this to, this is number 1. Now let's also have a number 2. And then let's have configuration 1 and configuration 2. All right, and now move configuration to configuration 1 and copy these ones around. Let's just verify builds. Actually, we can do both in one. Let's not. So let me not use my aliases here. Nix instantiate, that's what NI stands for in my alias. So that's just Nix instantiate, that just evaluates the attributes without building anything. Very convenient to just verify things work. And in this case, I notice it builds kind of too many things. I don't really want that. So when I just evaluate these configurations, so if we go in here, we can see these are declared as just importing from Nix packages / NixOS. And so these actually have more in it than we need. And we can see this when we see autocompletion here, config options, packages, system. We only want the system here. So we can do that, NixOS system 2.system, a bit redundant system here. But yeah, so this only evaluates the two systems now. Let's have, let's distinguish between these by using host name. So we say this machine 1 and the other one. Let's open this as well. Our 48 and configuration 2. Gonna put this in here. All right, and let's try building this again. Just see the host name, I think, should influence the resulting name here. Yes, indeed, machine 1 and machine 2. Question in the channel, where does the -a autocompletion come from? That, I think I have to check that. I do like it a lot though, it's very fast. So that's nice. Let me check, I think that might be C shell.
It goes with Nix.
I don't think that's included in Nix actually. Or it might, but I think if I go in here and look at C shell.nix completions, enable bash completion, that might be a thing, it might be that, enable bash completion. And I think that something like that exists for all the shells. If I look at the man page here, enable bash completion. So C shell has its own completion system, but it also allows you to use the completion system from bash as like a backwards compatibility thing. So that allows doing that. We also have enable completion. There's a bunch of things. I think there's also a package. So there is, I believe, let's use Nix REPL. Packages.nix C shell completions exists as well. There might also be, no, there's no Nix completions. But also, maybe let's give this a brief check. Do completions exist in the Nix package? So I'm on master here. It's fairly recent. Let me build the Nix package and then just do a tree on the result. Just see what is in there. So we have some binaries, we have some symlinks. By the way, this is interesting. It's actually all the same binary, but Nix distinguishes based on the zeroth or the first argument it gets, and so that will be the binary name in Unix. So then we have some etc. So these are some configuration files. etc profile.d. That looks a bit like completions. Let's check that out. etc profile.d. Although no, these look like init files, and probably the same one can be used for bash and C shell since they're fairly compatible. And yeah, that looks like it. So that's some init file that should get added to the shell startup when you install Nix, I presume. And we also have nix daemon.shell. I'm not sure what that is. That seems to be... I'm not entirely sure.
It's used when you install Nix with daemon. Then you should use nix daemon.sh. If you use
oh, I see.
without daemon, then you use nix.sh, I think.
I see. Okay, that makes sense. Nice. What else do we have? I used Nix tree. So we have libs. So these are all the libraries built by Nix. So these are not dependencies, these are ones Nix provides itself, although these are all, well, so mainly these libnix ones, they're not stable in any way, they're kind of internal. Then we have libexec, that's a nasty thing I don't really want to dig into myself. But here we have share, we have some completions, and indeed we have ones for C shell as well, although it seems to be only for the Nix command and not Nix instantiate and so on. But yeah, so if I use this command, and let's see if it also works. So let's try Nix. That would be, well, there's no instantiate in the new CLI as far as I know, unless there's a derivation flag here. I don't think so. No. So we have to use Nix eval instead. That would be f dot, and then the attribute name doesn't take -a, so it's just Nix system1.system, and now this would give like it would evaluate a lot of things, or it evaluates it recursively, so we get this very annoying and common error. So we can use outpath instead. Oh, and I wanted to try completion, so let's see. That also works. Yeah, okay, that works. All right, so, and actually I'm not sure myself, can we build multiple attributes in a single command? I imagine the answer is yes. Oh, looks like the answer is no, actually. Nix eval, oh yeah, okay, it only takes a single installable, though I think Nix build can take multiple. Yeah, that takes multiple. All right, so we figured that out, that's nice. Okay, now the question here was about using a port value from config A as a setting in config B. So let's find a service we might want to configure. So let's search for port here, and actually services .star port, so we get some service with a port, and 3 proxy Acme DNS AirSonic. I have no idea what that is. Maybe no, that should be fine. Come on. Sure, let's use AirSonic. Yes. All right, so let's do enable. So like this on machine 1, and these are flipped, but that's fine. So there's AirSonic enable equals true. Can nest this in an attribute set. Let's see. Well, let's hope this works as is. Let's just verify this. So I'm gonna Nix instantiate just the first system for now. And that does indeed work. Let's see, can we also build a VM and actually run it? I believe a VM might work. Yeah, let's try that. Might take, oh right, instantiate. Now we actually want to build the VM. This might take a bit longer. Meanwhile, let's see what this, actually maybe I should actually know what AirSonic does. Let's go to the homepage for that. Let's go nixos.org, and this is, oh, it's downloading a lot of things. That's why it's a bit slow. Actually, the stream might also suffer a little bit from this. But AirSonic, let's see what it does. Personal media streamer, that seems fine. Okay, and we also have the homepage here. Nice. Okay, I mean, I guess it's a free ad for AirSonic, although I haven't used this myself, so I can't recommend it. Also, maybe interesting, let's see for Nixos options here, AirSonic and enable. And is there also a package option? There's not a package option. So sometimes you have a package option to configure the package it uses. If that's not the case, war file to use. Oh, that's interesting.
Or is a Java package, essentially.
Well, I see. Oh, so I'm installing some Java stuff here. All right. But okay, let's let's finish the train of thought here. So if the service doesn't have a package option, but you still want to configure the package and have it use a different one, you can use the overlays option. So nix packages.overlays. So this allows you to change the package from within there. So let's, for example, say, let's actually look at the, well, it's a bit complicated because sometimes the service name doesn't match the package name. So you might be using AirSonic, but it might use AirSonic bin or something as a common pattern. So often it's a good idea to check the module. And so in this case, it should actually be fairly easy. We can just click on declared in to get to the module. And now I guess we want to search for packages to see here. Okay, it uses also ffmpeg, JRE, and here packages.airsonic. Oh, and this, oh, I see, this is what you were saying. So we could configure it like this, because this is the only place where it's used. Okay, yeah, so you could either overwrite the package with an overlay. Let's briefly just verify this. So this would look like overlays equals self super, or so traditionally self super. Nowadays, better names have kind of become the standard. Final prev. The order should be correct of these two. And so now we should be able to say AirSonic equals something here. Let's just verify this works by just having an error here. Now if we try to do this, it should give an error. Indeed. Yeah, and also if we turn this off, it would not give an error because the package isn't used. Let's try that. Well, yep, it evaluated, so that is as expected. And in here we would be able to say like AirSonic and then dot override etchers, something like that, or dot override any of these. And maybe, I mean, let's just also go in here because, right, we have dot override, but what can you override for these packages? Now that you cannot really find out from like directly from here. So you need to actually go into Nix packages and find where it's defined. This can be a bit of a pain. I'm going to hope that the file search in GitHub works here. So I pressed T to get to this here. AirSonic. And looks like it's defined here, default.nix. And looks like there's not a lot of, so these arguments up here are the ones you could override with .override. Looks like there's not a lot there. Really, it's really just a single file that's being downloaded here and moved to a specific place. Yeah, so we cannot even configure any like flags for compilation or anything like that. And maybe also this is an interesting field here, which indicates what kind of distribution mechanism is used here. I don't know too much about this, but let's maybe check this out briefly in the manual. I hope it's documented here. So this is the unstable Nix packages manual. I'm going to search for source provenance. And yes, it's documented here. So this is the provenance of the package's derivation output. So I'm not going to read through all of this here, but there's some values that you can get an idea. From source, we have binary native code. What's this here? Oh, binary bytecode. Oh, right, it's bytecode because it's code run on a VM interpreter or JIT compiled into bytecode. So this is it runs on the JVM, which is why it's bytecode. All right, so that's a good to have briefly covered as well. And so in this case, we can't really do much. I guess we would probably change the entire package or overwrite the source. That would be something we could do. So right, if you were to, let's say we overwrite the version, so we would do overwrite atters old, and actually let me use prev atters. And actually we can use the final prev pattern here as well. So there's two kind of syntaxes to overwrite atters now. The one with a single attribute set, in which case it's the one with a single attribute, single argument, in which case it's the previous attributes, and the final atters prev atters pattern, in which case these are the final ones and these are the previous ones, just like with overlays. And so we can say, so really just overwrite the source and a version. Yes. Well, I don't really want to do that. We've covered that a couple times before. So let me just say source equals null and then or ... and just comment this out like this. Actually, the entire thing here. All right, and so let's get back to this.
You don't really have to comment it out, right?
Right.
So if you just comment out source, then it will be just the same derivation in the end of the override.
That's true, yeah. That should be exactly the same derivation. Let's briefly verify this, and maybe that's a good place to kind of show off that. So we accessed the VM attribute, the system attribute, but there is also the packages attribute, which is the packages that the system gets. And so in here let's first do it without the overlay. and just get the, let's use Nix instantiate, because that already determines the final output. So air sonic. So we evaluate the package, so we get this hash. Now let's include the overlay, and it should be exactly the same. And that is indeed the case. But if we were to say, overwrite the version to like 10 dot, let's say 6.3, that should probably change it. Yes, that changes it. So the version is different, which means the hash is also different. Yeah, okay, so, but yeah, let's comment this out here. So it should be the same, and we built a VM. Let's just get this back. VM should still be in my result symlink actually, because Nix instantiate doesn't add anything to result. And actually, yeah, the warning here, well, if actually, can you do that? Yeah, you should be able to do that. So if you have like a system where, I know, it runs garbage collection like a lot, then you could risk that. So let's say you Nix instantiate and then you do something with that. So let's say drv equals Nix instantiate dash a Nix system packages airsonic. All right, so we get the drv, but we also get the warning. And now we have the drv here. And now let's say you want to build it, and so you do Nix store-air, but a garbage collection runs in between. And in this case, let's try simulate it with a Nix store delete. And well, it says it's still alive. I'm not exactly sure why, but this command is kind of broken, so I'm not sure how much information we can get out of this. Let's get this path here. Oh, it's the result. Oh, no, that's... Oh, it's okay, that makes sense. So make this a bit bigger. So it's being used in the result of the VM we just built. And that is because a VM, well, the VM uses the derivation, and I think I have this here enabled, keep derivations. I think that makes it so that any derivation you build, and then you have the build result that is a garbage collection route. It also makes all the derivation that depends on garbage collection routes, so they also won't get collected. And so I should be able to remove the result symlink. So let me do that, and then try this again. Delete, and still alive. What does it complain about now? And there is no result here. What if I run it with sudo? That sometimes has an effect. Yeah, I think that's the bug in the command. Let me, just because we're talking about it, let me go to the issue tracker and just search for Nix store delete. And this I might need quotes here. I'm not sure exactly about the GitHub search. No, that doesn't change anything. Root, let's try that. Okay, that's the same. There should be some, I think the workaround includes xargs, so let me try to find that. Yeah, this one might be it. Yeah, and there's a workaround in here, I believe. There's some finds in here, I think. One based on xargs. Yeah, this one. This one should generally work. So let's try this on this derivation. Might not work. Let me see. Reverse closure was also mentioned there. Nope. Okay, I think I give up for now. But so you can imagine the derivation can get deleted. It isn't being pinned by anything in yeah, it might not get garbage well, there's no garbage collection route referring to it, so it might get deleted. And so yeah, but we still have it in our variable. And so if we were to later try to do a Nix store realize on this, then this could fail, and we might not be able to build it because of that. Yeah, so realize builds a instantiated derivation. And oh yeah, the fix. So if you if you want to be really sure it doesn't get deleted by GC, you can do the thing that it suggests you to do, the add root. So we could say add root drv. Now it doesn't complain anymore, and well, it doesn't output the store path anymore, but we now have a drv in here, and this should be a garbage collection root. So if we say query roots of this derivation again, we can see it lists this one here. Right, and then I think, can we just do this here, realize drv? Yep, that seems to work as well. All right, now let's get back to, so we instantiate, oh, the VM, right. So let's do VM, is that still, that's not in the result anymore, right? We deleted that symlink, so we could attempt to delete the other store path. So let's just get it back here. And then I want to try running it. So we build a VM, run it with command, and we get a nice window. Actually, there's not going to be anything enabled in this VM. So I don't even have a login we could use here. So it will be kind of hard to test this. But well, let's, we have some VM configuration in an older Nix Hour, which I might be able to revive in the future. That was kind of nice. But for now, I think, can we do something like, maybe we could set up a VM test actually. That would allow us to confirm stuff about it. But maybe, so we want one machine to, yeah, we should totally have a test for this. But okay, let's go do the original thing here. So we have a port in here, so AirSonic port, AirSonic port, here it is. Right, so port equals, there's a default, but I'm gonna change this just for the sake of it. Let's say 4041. Okay, now we want this machine, let's say it should, let's say we install a command on it that pings the machine. That'd be interesting. So we say system packages, let's all declare it in here for now. This is not super good practice, but the Nix language does allow this, so we just wrap it in parentheses and then let in definition here. Let's say pinger will be the package that will do the pinging. Let's say write shell application, I think that's one that exists. Pinger bin might also be necessary. So we just write this in here, pinger, and we do a ping of the other machine, I guess. In that case, we will need, let's assume it's in the hosts, extra hosts as machine 1. Can we do this ping? Oh right, ping, no, ping doesn't use a port. That's right, we would have to use like a TCP ping, which is, don't fully understand. So let's use NC instead. NC is a way to kind of just connect using TCP to machine. So for example, right, this is localhost. We could say, let's say nc nixos.org. And then which port? Let's say 443. And let's use -v, and we get connected to this one. Whereas if the port would be wrong, like let's say 444, it would not do anything. Depending on what the machine, on what the server machine does, this would, in this case, it looks like it just ignores the request, and so we don't get any results. And 80, we can also try that, yet that is being listened for. So nc -v, and then we use the machine 1 and 80, or no, not 80. Right now comes the thing about how to refer to this other machine. And so by default, there isn't really a way to do that in NixOS, so you need to somehow pass this machine to the other machine. So we can do this by, well, in our default.nix, we have them configured like this. There is, I believe, the, well, configuration. Let's just briefly, let me refresh the arguments that we have here. So this is just configuration in the default.nix, which we import here. So I guess we can't pass special args here, actually. That's a bit surprising. Yeah, we have eval config, which we could import, and I believe that would have some extra options. Let's see about that. Yeah, so here if we use eval config, we could pass special args and extra args, but these are, actually this shouldn't be, this is a bit weird. Modules check, yes. So let's do that, and actually then we will also get closer to what flakes, or what the convention is in flakes, because there you also have a function that is pretty much that. So eval config.nix. And maybe a brief note on like the API surface of Nix packages. You can import any of these files and use their Nix expressions, but a very small part of them are actually meant for that and are ensured to be compatible in the future. So this eval config, is it mentioned up here? It doesn't say anything about the stability of this file. Would be useful, but I guess we're using it here now. I think it's used in other parts of Nix packages already, so that would be fairly stable. One of the main files that you can rely on is the default.nix. That's obviously the file that you get. I mean, when you evaluate Nix packages, that's the value that determines. That's the file that determines the value. So that's fairly important to stay compatible into the future. But yeah, so these files, decent. Maybe they will change in the future, so that might break. But let's live with it for now. And so here we should be able to pass. Where's the Nix? Default? Oh, it's lib eval config. Lib eval config. Yeah, I think we should be able to use an actual function later. But so yeah, this actually doesn't take configuration anymore, so we need to pass modules instead. So now we have two options. We can use special args. These are arguments you can't influence from the modules, but they allow you to use the arguments for imports. Do we need this? We don't need this. So I would prefer using args. So that's module.args. And then we set so the easiest way to just propagate one thing. So in this case, we want to propagate something to machine 2 from machine 1. So let's change machine 2 down here. So 2, okay, this can stay the same. So now we set air sonic port, let's use a camel case, is, and now we need to pass in the value from this system. We can get this from self.nixos system1. And now we have the same value that we've been exploring on the CLI. So let's use another property from there. So we have, let's use the Nix REPL this time. Oh, and there's a syntax error in here. So let's comment this out for now. So Nixos system 1. Now we've seen packages, we've seen config, and oh no, we haven't seen these. So this actually changed a bit now. Previously we used this file here, nix packages nixos, and then write the default Nix file in there. But that apparently exposes a different resulting value. Let's maybe briefly compare these. So we have import Nix packages nixos, and pass this for now. Oh, and let's just do attr names like this. So these are the ones exposed here, but now we use lib eval config.nix, and that needs modules. Let's pass just the empty ones. Just get back the other ones. So yeah, there is now. So these are kind of convenience attributes exposed. So these are kind of more stable. And these are useful for the NixOS rebuild script. So if we were to look at that, so let's use vim which NixOS rebuild. We can see here, so this does Nix packages nixos. Yeah, we can see this here, and it uses, well, it doesn't, no, it uses config here. Here it is. Actually, no, this is also config. Not the right thing. Here it is. Yes. So it uses this NixOS path, and then it gets the system attribute. So this should stay backwards compatible, but it doesn't expose everything. And we also saw that earlier. And here in the NixOS file. So it just passes on packages, config, system as declared, and we used VM from here. But we can also see how we can get from this eval config to these individual values. And so in here, what we now can do is, so self.nixos system1 dot, and now we want the config. And so this will just be config. And then we have all the options from Nixos in here. So we can say services.airsonic.port. All right. Now I should be able to, in our configuration 2, to get this as a module argument. And so let's do that, airsonic port. And we need to add dots here. And we can insert the port here now. Do we need a toString? We do need a toString because it's an integer. All right, now let's verify it still succeeds. And now we won't be able to use this anymore because we now use this eval config, which just exposes, well, kind of a limited set, and the system here can't be built directly. This is a bit of a pain though. Let's just build system 2 for now. So this would be config.system.build.top level. And undefined variable packages. Right, we reference packages here. Let's add this. And Oh, right, shell application bin. Okay, that's not a valid name. Let me look in the Nix packages manual. There should be a trivial builder section where these are kind of documented. There is one missing here, which is it maybe only in the unstable one? Actually, I don't need to edit the URL. I can just do it down here. Trivial builders. There's right shell application. Did that exist in stable? I can't remember, but this is the one I was trying to get. And you can also use runtime inputs here. It's kind of useful. Oh, and this takes an attribute set. I guess the main advantage of this is that when you have dependencies like this, and actually we do have a dependency, and that's this nc command. I don't think it's installed by default, so we will have to add that. So it sounds like a good option. So it's write shell application. Okay. Now we need the name. Name is pinger. We have runtime inputs. Now we need some nc. Let's do that later. So the text will be just this. And let's close this properly. And I mean, we don't necessarily need a let in here, although let's actually take this opportunity to refactor this let to be up here. I guess, I mean, that's a code architecture question about where your let bindings should be. Arguably, it's better if they're scoped to as little of a scope as possible. But for now, I'm just going to do it like this. So install the pinger, and let's try building this again. Oh, right, syntax error. This nc up here. So now let's use this to get... Actually, I'm not sure if the search page shows binaries. I think it might. So let's search for nc. I thought it... Oh yeah, here, programs provided. So Nix search does show you that. And actually typebox, let's see, does it provide nc? It doesn't seem to. nc is unfortunately kind of a hard thing to search for, and I don't remember there being a better syntax for this. But yeah, let's go down a bit here. So this is the one I would probably recommend, netcat GNU, but there's also just netcat. Let's just briefly check which one I have installed. We can do this by looking at which nc, but this doesn't really print the full path. I want the full path, so real path of this. Oh, this comes from LibreSSL. Why is this in my system? That's a good question. And we can
Toolbox provides it.
Answer that. What?
Toolbox does provide nc.
Oh, does it? Ah, okay. I think the search results went to the left there first. Yes, it's here. But yeah, question, why is this in my system? Let's briefly use Nix ydepends. I'm going to use run current system and then this path. And we can see here, well, it's my system path. That's kind of obvious, but I guess it's probably in my system packages somewhere. And I guess for that we would have to, well, actually we could track this back even more by loading this in the REPL. Let me briefly do that. I'm going to load my configuration, and I have a bit of a custom setup here, but this is node sign. We can get the configuration. Oh, and actually no, this will be really tricky. Let's not do that. Yeah, I can't get access to the option definitions in here. easily. So let's not do that. So instead, let me just try to use netcat GNU, or I mean, we can use Tybox and just see if it has the same user interface. Let me briefly do that with a Nix shell, or actually Nix run. Let's use Nix run for now. Tybox, and oh, actually Nix run. No, there's no default binary, so Nix run wouldn't really work that well here. I think Nix shell should work here though. Tybox. All right, please download that for me. Evaluating Nix packages. Any second now. All right, now we should have that in path. Let's just verify this. Yes, it's here. So now NC help page. It's also NC nix.org. Oh, and the dash V. Oh, it doesn't have a dash V. So is there anything else we could use? Not really. So instead, let's try to use the GNU. What is it? GNU netcat GNU. Netcat GNU. All right, nc-v. That does work. It prints something different, but that should be good. Yes. All right, so we use netcat GNU from the packages. All right, now let's instantiate this again. Instantiate the system. And that did work, so it evaluated. That is one solution we can use here. So that's passing it kind of in the kind of surrounding file where you declare your system. Maybe something else here. Args here, like the module arguments, are really just kind of an untyped set of options. And so that's generally not my recommendation. Yuri?
But since we didn't add special args here, we just added some options, right? We didn't have to actually use eval-config here, right? We could just set configuration to like a configuration that will import configuration2.nix and add these options, right?
That is true, yeah. There is a bit of a... There's a bit of a... So each of these imports and calls of these functions will be a separate NixOS instantiation. And so if we... So let's say we go into configuration 2, right? I think that's what you meant here. And just say... Actually, where is it? Oh, here. So we could say this here and say system1 equals, and then do kind of like this.
No, I meant on the outside. Like if we set, if we import Nix packages NixOS, and then just configuration equals set with import for configuration.
Yes.
2 and model.
That's true. Yeah. We could do this as well. So just import NixOS and then just set configuration, and then it's like this. And then we could say imports equals this. And then down here we set the module args. Yeah, that's a good idea, and kind of makes this a bit simpler again. So like this, and actually, yeah, let's do that. Here, same NixOS, and configuration is configuration 1. And that looks decent to me. And the idea I was saying was that you could also do this here. So you could say Nixos system 1 and essentially copy this into here. And then evaluate configuration 1 from configuration 2. And then we wouldn't have to use the argument here, but this is much slower. Also, if you evaluate both systems, it will evaluate 3 systems in total, because now there's system 1 gets evaluated once and then a second time here. But let's just briefly verify this also works. config.airsonic.port, actually services. So like this, and now we can actually use system again here. Undefined variable sources. Did I mess something up here?
It's in configuration to the Nix use sources.
Oh, yes, thank you. Oh, well then, I mean, I guess we need to pass sources in then, which, I mean, I guess we can do. But, I mean, let me just cheat a little bit here and just import it impurely, just to speed this up a little bit. All right, it's doing stuff. Yeah, it's using a different one now, but it does evaluate. So this is an option, but it's slow because it evaluates it multiple times. So don't do that. Let me get rid of this. But so something else I wanted to show is that, right, options or module system arguments are really just options, but kind of untyped. And so generally what I'd recommend is be more like willing to just declare your custom options. And so in this case, I could say this is AirSonic listen or target port, or options of machine to one AirSonic port, like this. So we can declare this using make option. Now here we can give a type, and so we can make sure we can expect the right type here. And so this would be the .types.port, useful type just for ports. And then we can set a default here, a nice way to set a value right in line. Okay, default self, that looks good. We need to add lib here though. Let's do that. Okay, and now we need to change this here. So instead of using the argument from here, we can get this using config, and now it's config.machine1 AirSonic port. All right, let's verify this works.
Can you copy type from the option, from AirSonic.port option?
I can. That should be possible, yes. So we could do that using, so that uses another attribute in here. And so this is options. This allows you to get kind of metadata about all of the options. And so here we could say services.airsonic.port.type, actually. That kind of looks very nice. Let's just verify this again. And now this kind of leaves the question if we can if there's a way to make this even smaller. I can't think of one right now, actually. No, not for the type and the default. But yeah, so this also works. But now we need, so this is a bit annoying if you want to propagate and use more things than just like a single port. So let's say we pass in like all of the systems. So let me do this by nesting this under like Nixos systems. Then we have say foo, and we have bar, Okay. So we have this attribute set, which contains all of the systems now, and we want to propagate that into all of the systems, so they can access anything from the from all of the systems that they want. And we can do that by, so we could use an option again here. Yeah, let's use an option. Generally, that's a pretty good idea. So let's say all machines, let's call it that. Now the type of this, what should it be? Now lib.types, it's going to be an attribute set. But I don't really want the module system to check anything inside of these values. This is not something, like it doesn't declare any options inside of it. This is a resulting value, at least how we declared it here. And so what I can do here is use the type raw. Raw is kind of this, it's just a raw value. It doesn't really go and check anything inside of it. Let's also assign the default. So this is just self.nixOS I think, yes. And I notice here I used self and final in another place, but that's fine for now. And let's also maintain this systems.foo, so this should also continue working. And let's also, so we'd want this to be there for both of these. For this, maybe let's do like let in here. And let's say that's the all machines module. And so this module, we declare it up here so we can share it between the two machines. So we move the option declaration in here. And let me just fix indentation here. I think like this.
You need to add lib to that module.
Oh yes, thanks. So lib, okay, and then configuration, and let's do the same thing here where we say imports equals on one hand the configuration and on the other hand the all machines module. Okay, so we have that, and same here, all machines module, so we can remove it from here. We'll keep this one around just because for history, I guess. And NixOS systems, right? We need to now NixOS systems and foo.system. All right, this should work. Yes. Well, we aren't using it anyways for now. We are almost out of time. Let's hurry up here. Something else I want to do here is, well, actually, this is fine, but you might also want to like map address this, actually lib.map address, to say system or address.system. This way you would only pass the system. Actually, no, system isn't very useful. Config would be more useful, but you can map this value as you need. This would be kind of the most general one though. So now we could also do in here, so config, not machine 1 AirSonic port anymore, but we could say config.all machines dot, now the machine name, so we want this is bar. Now config allows us to access the config of the machine, services dot AirSonic dot port. So we directly access this. This, I think, oh, yes. Oh, thanks. Foo, very nice. Oh, actually, I evaluate foo here. I think I want to evaluate bar. Yes. Yeah, so that works. We could maybe briefly check this bar, depending on how long it takes to build. We could check the, actually, let me go up here. Is the pinner, oh yeah, the pinger is mentioned in here. as the derivation. Let's just do a Nix store realize of this one and cat the result. Cat the file here, and we can see here the port is indeed the right one. So it worked. All right, we are out of time though. Thanks for joining, and see you in the next